All right, in this video, we're going to talk about how to teach graphing tangent and cotangent. Now, if you've watched my video that's about how to teach graphing sine and cosine, the process will be very similar. So let's get started. The key to graphing any tangent or cotangent curve is to be familiar with the 5 key points from their parent graphs. This is the same for sine and cosine. So here's the graph of the tangent function. And when I talk about the 5 key points, I'm talking about this point right here. We have an asymptote. Then you have I'm calling your low point. Then you have your pivot point. It's really a point of inflection. And then you have your high point, and then you have your other asymptote. And so that gives you one cycle or one period of the tangent curve. So students need to be familiar that the tangent curve happens, the parent tangent curve happens between negative pi over 2 and pi over 2. And then your low point is at negative pi over 4, and then 0, and then pi over 4, and then pi over 2. The cotangent curve, of course, is a little bit different. You still want to find one period or one cycle that's between 2 consecutive asymptotes, but this time that occurs at 0 and pi. If you're thinking about the unit circle, by the way, you can connect the cotangent curve to be like quadrants 1 and quadrants 2, because it's going from 0 to pi, but your tangent curve to be from quadrants 1 and 4. So sort of pivoting to the clockwise and counterclockwise on your unit circle. Similar kind of thing, we have your asymptote at the beginning and the end, but this time you're going to start with your high point at pi over 4, and then your pivot point at pi over 2, and then your low point at 3 pi over 4. Let's take a look at some examples. So to sketch the graph of 3 tangent of 2 times x minus pi, I'm sorry, my font made this a capital tangent. I don't really like that. I would prefer that it be lowercase. Okay, sketch the graph of 3 tangent of 2 times x plus pi. We're going to start by doing a little bit of analysis here. So I know that this is going to be a vertical stretch by 3, or by a factor of 3. Now, I would not say amplitude here. I have a real issue when students and some teachers would say that the amplitude is 3 because the tangent curve does not have an amplitude. It does not have a maximum. Similar with the cotangent and, of course, the secant and the cosecant. Then we talk about the period. The period here is going to be just pi divided by the b value, which in this case, the b value is 2. So it's going to be pi over 2. Now, as far as the transformation is concerned, we could describe that as being a horizontal shrink by a half. Now, what we're going to do when we get to our t-table is we're going to multiply the x's by a half. We'll come back to that later. Let's carry on with our transformation. We do have a horizontal shift or phase shift, we could call it either one, horizontal shift or phase shift. And that's going to be left pi or negative pi. I would accept either one for my students. And we're going to have no vertical shift. Okay. Now, when I was here and I said that the period, which is the horizontal shrink by half, means you're going to multiply your x's by a half. Let's go back up here to our vertical stretch by 3. So your vertical stretch, of course, is going to affect the graph vertically, which is your y coordinates. So this means we're going to multiply the y's by 3. And down here, our phase shift left pi, that's affecting your x's. So here we're going to have to subtract pi from the x's. And of course, we don't have a vertical shift, so we don't need to do anything there. We have 2 transformations that affect the x coordinates and only 1 transformation that affects the y coordinates. The order matters here when we do the transformations that affect the x coordinates. We need to do our multiplication before we do any addition or subtraction. Otherwise, we're going to get the wrong graph. So I'm going to start with my t-table from my parent graph. Here's the t-table for my parent graph. Now I need to transform these values. So I'm going to make another t-table. Notice in the t-table that I'm labeling this column y because my graph is called y. And in my original t-table, I called it tangent of x. So that's just for the parent graph there. There's only one transformation that's affecting the y coordinates, and that's pretty easy. Just multiply the y's by 3. So I'm going to go ahead and do that. We'll take all of these y values and multiply them by 3. Of course, if you have undefined and you multiply by 3, well, you can't really do that. It's really still undefined. So that's at the beginning and the end. Then negative 1 times 3 is negative 1, then 0, then positive 3. For my other transformations, I'm going to first multiply the x's by a half, and then I'm going to subtract pi from them. It's going to be a little bit annoying fraction work here. And if students are doing this without a calculator, then they're going to maybe want to do some of the work in the margin. Let's take negative pi over 2. We're going to multiply by half, and we're going to subtract pi. Negative pi over 2 times a half, and then you're going to subtract pi. So it's going to be negative pi over 4, and we can turn pi into 4 pi over 4. So that's going to give us negative 5 pi over 4. Okay, I'm going to do one more with you, and then I'm just going to give you the answers to the rest to save on time. So the next one, we're going to have negative pi over 4. We're going to multiply by a half, and then we're going to subtract pi. So that's going to be negative pi over 8, and pi, we can call that 8 pi over 8. So that's going to give us negative 9 pi over 8. And if you do that with the rest of them, you're going to end up with negative pi, negative 7 pi over 8, and negative 3 pi over 4. I'm going to erase that. And now it's a matter of setting up our axes and our grid and then plotting the points. So I can see on my x that I need to basically, I'm only to the left of the y-axis. And I'm essentially going by eighths, right? Because this is really negative 10 pi over 8, negative 9 pi over 8, negative 8 pi over 8, negative 7 pi over 8, and negative 6 pi over 8. So if I were to make little tick marks for every like eighth of pi, so that's 1, 2, 3, 4, 5, 6, 7, 8. So that'll be negative pi right there. So that's negative 8 over 8. That's negative 9 pi over 8. And then that'll be negative 10 pi over 8. So let's label another one. This is going to be negative pi over 8. And that'll be negative 2 pi over 8. This will be negative 3 pi over 8. Negative 4 pi over 8. That's going to be negative pi over 2. Something like that. Okay. And then for my y, I'm going to label it 1, 2, 3. And then 1, 2, 3. Now you'll notice that I just started here with just a blank space, and I added my own axes and I created my own little grid lines here. If I were doing this with students, I mean, this is how I would exactly teach it to my students. You can also give your students just like graph paper that doesn't have any lines or anything labeled on it. That's what I would do, because I find that if students are already given a grid and it's already kind of has like 16, it's just like a box and already has like 16 little grid lines here, then they have trouble really trying to figure out how to label their scale. And then they'll do their scale way, way off. Like they would call the first one like negative pi over 8, and then they call the next one negative pi over 2. And I'm like, that's not right, because you're saying that the distance between 0 and the first grid line is pi over 8, and the first grid line and the second grid line is not that. So their scale is totally off. So that's why I encourage them just to kind of look at the most basic difference here. That's why I sort of saw, oh, this is negative 9 pi over 8. That's really negative 8 pi over 8, negative 7 over 8. So then I just went by eighths for my scale. All right, now I'm going to plot some points. So negative 5 pi over 4, so that's going to be there. And then negative 3 pi over 4, that's negative 6 pi over 8, so that's going to be here. And then at negative pi, we're at 0. At negative 9 pi over 8, we're down at negative 3. And at negative 7 pi over 8, we're at positive 3. And then, of course, we want to draw the shape of the tangent curve like so. And we're done. It's not really perfect, but we can pretend. And then if I wanted to do another cycle or another period, then I can see that I've got 1, 2, 3, 4 grid lines between my axes. So I can go 1, 2, 3, 4, put another axis there, and then I'm going to have another like little branch of the tangent curve there. It didn't specify that I had to show 2 periods or 2 cycles of it, so I'm just going to stop there with the 1. Let's take a look at our next example. All right, here's our next example. Again, I don't like that this is capital letters. I wish I had fixed that before I started recording the video, but whatever. Same thing. So cotangent, remember the cotangent curve has this general shape to it. It's sort of down and negative. I always say this is sort of like the tangent is like the captain and the cotangent is like the co-captain. The tangent is very positive and optimistic, and the cotangent curve, he's very pessimistic because he's just the co-captain. He doesn't feel like he has any real role in life, sort of like a vice president or something like that. So cotangent curve, let's discuss the transformations here. We know we're going to have a vertical stretch by a factor of 2. We're going to have the period here. Our b value is a third, so your period is going to be pi divided by a third, which is 3 pi. You're going to have no phase shift, and you are going to go down. So for the vertical shift or translation, that's going to be down 1. So how is that going to affect the x and the y coordinates? Well, just like the other one, the vertical stretch, that's going to be multiply the y's by 2. The period, that is 1/3 there. So that's actually going to be a horizontal stretch by a factor of 3. So that means that we're going to multiply the x's by 3. No phase shift, and then the vertical shift down 1 means we're going to subtract 1 from the y's. So this time we have two transformations on the y, the vertical stretch and then the vertical shift, and only one transformation on the x's. And the order matters. You want to do your multiplication before you do any addition or subtraction. There's my t-table from the parent graph, and I'm going to transform all of those values. So there's only one transformation happening on the x's, which is to multiply all those x values by 3. So I will multiply all of these x values by 3. So I will get, and then for my y values, I need to first multiply them all by 2 and then subtract 1. Of course, with the asymptotes there, those are just going to stay asymptotes. So we're going to take the 1, we're going to multiply it by 2, so that's going to be 2, and subtract 1, which puts us back at 1. And then 0, multiply that by 2, that's going to be 0, and subtract 1, that's going to be negative 1. And then negative 1, multiply that by 2 is negative 2, and then subtract 1 makes negative 3. And now we set up our axes. I'm noticing that my x's, I start at 0 and I go out to 3 pi. I also have to plot like 3/4 and 9/4, so I might want to see if I can either do tick marks by 1/4 or maybe tick marks by 1/2 and then just kind of go in between. So let's see if I go, so now I do have tick marks for the 1/4, and then for my y-axis we can just go 1, 2, and then 1, 2, 3. Let's label that. This is going to be a negative 3, negative 1 is going to be a positive 1. So let's plot some points. So for our asymptotes first, we're going to have an asymptote at 0, so that's right on top of the y-axis. And then another asymptote at 3 pi. And then 3 pi over 2, that's basically 1.5. So if that's going to be 1 pi, that's going to be 1.5 right there. We're going to be 3 pi over 2, negative 1. I'm kind of going in between. I know I skipped over 1, but I was just thinking about in terms of halfway through. So halfway between your axes is going to be your little pivot point there. So right there. And then halfway between your pivot point and your asymptote will be your other, in this case, it's going to be your high point. So 3 pi over 4, that's going to be this third grid line in. And you can see 1, 2, 3 more takes you over to your pivot point. So 3 pi over 4, 1, we'll put a point there. And then 9 pi over 4. So again, that's going to be halfway between this pivot point and our asymptote will be down at negative 3. So that's going to be, because this is like 1.5, or in other words, if I put that in fourths, that's going to be 6/4, 7/4, 8/4, 9/4. That's going to be right here down to negative 3. And then we connect them with the cotangent shape, something a bit like that. And there we are.